This is Advanced Math, Unit 11, Lesson 5. Hyperbolas. Hyperbolas is the last of our conic section shapes that we're going to be dealing with. We will have one more day of hyperbolas, but this is the last new shape. Okay, standard form. The quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared equals 1. Okay, hyperbolas are the only ones that have two squares, an x squared and a y squared, with the minus sign. One of them is negative, not both, just one. One's positive, one's negative. If that ever happens, it is a hyperbola. Okay, just a quick reminder, because you have done these before, a hyperbola looks something like this. You're going to be drawing like a box shape, and you'll have these asymptotes, and then you have these parabola-like shapes on each side. Okay, so if you remember that from last year. Okay, so it looks something like that. Your vertices, this would be your center, these would be your vertices, and your foci are always inside the cups. Okay? When we draw our box shape, which we will be doing eventually, I didn't do a good job on that one. Anyways, they'll be outside your box shape, which we will see once we start drawing them. Okay. Now, because subtraction is not commutative, addition is. So with an ellipse, it doesn't matter if it's x squared plus y squared or y squared plus x squared, because addition is commutative. Subtraction is not. So if I were to flip it and do y minus k quantity squared over b squared minus x minus h quantity squared over a squared equals 1, I will end up with a different shape. It's still a hyperbola, but it looks different. So I don't know if you guys remember, but I am going to show you. Assuming the center's at the origin, you will still have these asymptote type lines, which we'll figure out how to draw in just a little bit. But your parabolas will be opening, or not parabolas, your hyperbolas will be opening up and down. Hyperbola will be opening up and down. So right and left or up and down. Right and left when x comes first, up and down when y comes first. However you want to remember that. Right and left when x comes first. I've had kids say, well, if you put these two curvy lines together, it looks like an X. That's how they remembered it. And then these two make, these two are when the y comes first. Okay, and the same here, the vertices are always inside the cup. So the vertices and the foci, okay, I think I said that wrong. The foci are always inside the cups. The foci are always inside the cups. The vertices and the foci have nothing to do with the major axis. Nothing to do with the major axis. Keep that in your head. Major axis is only for an ellipse, not for a hyperbola. We don't care about the major axis here. What matters is what comes first. Okay, so I'm going to say that again because I'm not sure if I messed up in the beginning. So here it is. The vertices and the foci are not on the major axis. It depends on what letter comes first. If the x comes first, the vertices and the foci are going to be right and left. If the y squared comes first, the vertices and the foci are going to be up and down. Nothing to do with the major axis. Okay? X is first. It doesn't matter if it's bigger or smaller. Everything's going to be right and left. Your graph, your vertices, your foci. If y comes first, it doesn't matter which one's bigger. Everything's going to be up and down. Your graph, your vertices, your foci. Okay. Center is still HK, just like it has been. And focal length formula is c squared equals a squared plus b squared. Notice I did not put any absolute values. Not necessary when you're adding two positive numbers. A squared plus b squared, if I'm adding them, I don't have to worry about absolute values. One thing to think about, hyperbola has a minus sign, but the formula has an addition sign. Where with the ellipse had a plus sign here and a minus sign in the focal length formula. So remember that when you're working it through. Okay, some quick definitions. Length of transverse axis and the length of conjugate axis. Okay, you do need to know these definitions for not only your work in class, but for the quiz and the test. Okay, transverse axis. The length of the transverse axis is the distance between the vertices. Okay, these are the vertices, find the length between. These are the vertices, find the length between. It's not always going to be the major axis. The length of the conjugate axis is the distance between the points that are not the vertices. That are not the vertices. Okay, so everyone remember that. Transverse are the length between the vertices. The conjugate are the non-vertice points. Okay, equation of an asymptote, of the asymptotes, because there are two. Equation of the asymptotes, and this is another one you will need to know. The asymptotes are always linear. Do you see that? They're always going to be straight lines, and you have choices. You can use y equals mx plus b, which is point slope form, or you can use y minus y1 equals m parentheses x minus x1. This is point slope form. This is the one I suggest you use. This is the one I will always use when I'm doing these problems with you in class. Easiest to use, the one I recommend you use, the one I will always use. You can use this one if you want, but it's going to make things a little more complicated. Okay, the two things you need here is a point and a slope. M is your slope. We'll talk more about how to find your slope when we do an example. And your point, your x1 and your y1 is a point. And we'll talk about what that point is, or how to easily find the point. Oh, actually, we can talk about it right here. Can you see that your vertices will always go through the center? Now, the center is not always going to be at the origin, but the vertices will always go through both, the asymptotes, sorry. The asymptotes, both of them will always go through the center. Dot, 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 that's one. Dot, 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 that's the other. They will always intersect at the center. The center will not always be at the origin, but the asymptotes will always intersect at wherever the center may be. So this point we're going to use will always be the center. Why? Because whatever that center is the one point the two lines will always have in common. Okay, we are going to do an example. Okay, number one, sketch, and I'm going to have you find some important pieces. Let me write the equation down first. Parentheses y minus 3 squared over 4 minus parentheses x plus 1 squared over 36 equals 1. We're going to find C for center, V for vertices, F for foci, the length of the transverse axis, the length of the conjugate axis, and the equation of our asymptotes. I'm just going to put a line for that. Equation of the asymptotes. Okay. Let's see if we can get this. Okay, center. Opposite of the insides. Now, a common mistake kids will make is they'll say 3, -1, where it's really -1, 3. You want to be careful. X stays with X, Y stays with Y. Opposite of 1 is -1, but it goes in the X spot. The opposite of -3 is +3, and it goes in the y spot. Okay, so let's go ahead and plot that. I'll try to make my graph big enough to get everything in it. Okay. Go ahead and draw your coordinate plane. All right, I'm going to plot -1, 3. And how do I graph this? I started off just like I would an ellipse. Be careful, A is 6 and B is 2. Kids automatically, because we spend so much time with the ellipse, they say, oh, I'm going to do, this is A and this is B. No, with the hyperbola, it can be flipped around. A is with the X, B is with the Y. A is 6, B is 2. X is right and left, Y is up and down. So right and left 6, up and down 2. Okay, 1, 2, 3, 4, 5, 6. It looks like I ended there. 1, 2, 3, 4, 5. And then left 6. 1, 2, 3, 4, 5, 6. Looks like I ended there. 1, 2, 3, 4, 5, 6, -7. Okay. And then I go up and down 2. 1, 2, 3, and then I go up and down 2. 1, 2 puts me there. 1, 2, 3, 4, 5, and then down 2 puts me there, which is at 1. Okay, this is at the point where I would make an ellipse if this were an ellipse. I'd make my big long oval shape, my major axis would be this way, but it's not an ellipse, it's a hyperbola. So we dot, dot, dot is what you do. You, instead of making the oval shape like we did with an ellipse, we make this rectangular shape here. And I dot, dot, dot it because this is not part of my graph. This is just to help me figure out where the asymptotes are going to be. Okay, so we dot, dot, dot. Our asymptotes will be the diagonals. They'll go from corner to corner through the center. So these are also dotted because these are not part of the graph. I'm going to try to get this in there the best I can. Okay, that's a really horrible line. I will fix it. Okay, continue drawing it. Your diagonals going across. Okay, let's see if I can do this again. Okay. You will have graph paper on the test, so it's not going to look as horrible as mine does. Okay, so these are the asymptotes. As you can see, it depends, like if my hyperbola was opening up and down, it would be really wide. If my hyperbola is opening sideways, it would be really narrow. So these asymptotes do determine how wide or narrow your graph is going to be. Now, because the y comes first, it is going to open up and down. So it's going to be here and here. Those are going to be the points at which my graph gets grows wide from. And because it's up and down, you can see that it is going to be really wide because it goes towards those asymptotes. Where if the x had come first, it would be really narrow in comparison to this really wide one. Okay, because I approach the asymptotes. Okay, so remember what I said. The vertices and the foci are not on always. They can be, but they're not always on the major axis. It all depends on what letter comes first. So since the y came first, everything is up and down. The graph, the vertices, the foci. Okay, so these are the vertices. Kids will often say, oh, these are the vertices because they're furthest apart. No. They could be, but in this case, y is first, so they are not. Okay, so these 2 points here, so that is -1, 5, and -1, 1. -1, 5, -1, 1. To find, oh, let's do these really quick, transverse and conjugate, because they're easy. Transverse is the length between your two vertices, which happens to be the smaller ones. They could be the longest, but in this case, they are the smaller. From here, I went up and down 2, total length of 4. Conjugate's the length from the 2 points that are not the vertices. These 2 points here are not the vertices. If I went right 6 and left 6 from the center, that's a total length of 12. Okay, transverse is not always smaller than the conjugate. Could be larger. It just depends on the problem. All right, in order to do the foci, we need to do our focal length. C squared equals A squared plus B squared. 36 plus 4. Because it's addition, you can do 4 plus 36. It doesn't matter. C equals the square root of 40, because I take the square root of both sides. C equals root 40. Break it down. C equals 2 root 10. So from here, I'm going to go up and down 2 root 10. I know 40 is between 36 and 49, so the square root of 40 is going to be somewhere between 6 and 7, 6 point something. So now here's another place kids mess up. They do it from the vertices. It's from the center. Everything's from the center. Right and left from the center, up and down from the center, and for the foci, from the center. I'm going to go up 2 root 10 and down 2 root 10. Remember we said root 40 is like 6 point something. 1, 2, 3, 4, 5, 6 point something, and then down 1, 2, 3, 4, 5, 6 point something. Okay, and you can plug it in your calculator to get a better estimate. That there is the graph. Now the way you write the foci, because they're not whole numbers, they're radicals, from the center I went up and down, and when I move up and down, I'm moving up and down 2 root 10 because that is my focal length. When I move up and down, it's the y value that's changing. It is the y value that's changing, and the x value is staying the same. Can you see that? I'm going to go left 1 and up a certain distance to that star, and then left 1 and down a certain distance to that star. So the -1 is going to stay. Comma, the 3 is what's you're going to add and subtract from the 3 plus 2 root 10 and 3 minus 2 root 10. So it looks like that. That's confusing. We'll talk more about it in class. Okay, equation. We need a point and the slope. You can see the point here. Like I said earlier, the center is always the point at which the two asymptotes are going to cross, and that center is -1, 3. What is our slope? The slope is rise over run from 2 points. I know this is a point the 2 lines go through, and I'm going to look at this one first. I know the line goes through that corner. I know that because that's how we drew our asymptotes. I told you they were diagonals and they go through the corners. So from here to here, I'm going to measure rise over run. I go up 2, and I know that because I went up and down 2. And then I go over 6, 1, 2, 3, 4, 5, 6, and I know that because I went right and left 6. So it's up 2 over 6. I will reduce it in just a little bit. Up 2 over 6. And to this corner, because there's another asymptote, I still go up 2 but left 6. So I'm going to put slope as plus or minus 2/6. Up to right 6, up to left 6. They have the same slope, just one's positive and one's negative. Positive slope, negative slope. Plus or minus 1 over 3. Okay, so our equation is y minus 3 equals plus or minus the slope, 1/3, parentheses x minus -1, which is plus 1. And that is the equation of your asymptotes. You will need to know how to do that, so if it is kind of confusing, we'll get more practice in class together, but that's pretty much how you work these out. One thing you should notice about your your slope, it's always rise over run using these values. We'll talk more about that in class. I'm going to give you one that we're going to do together. Number 2, x minus 1 squared over 1/4 minus y plus 5 squared over 1/9 equals 1. You can try it on your own. This one's a little crazy because of those fractions, but still doable. That is it for this lesson.